So this should work now. Hey, welcome everybody. Thank you for joining us to our today's session about writing your own operator in Java. If you could please just write into the chat if you can hear me and see the slides, that would be awesome. Just that everyone is able to hear and see us. So I'm not getting any messages, which either means none of you found the chat. Yeah, there you are. Thank you very much. This is fine. Thank you. Yeah, I see already people still trickling in, but we will start, and so we have the full hour to show you guys how to use the Java Operator SDK. Today I'm joined by two dear colleagues from Container Solutions, which is Charlotte and Adam. Maybe you guys want to introduce yourselves, Charlotte?
Sure, thanks. I'm Charlotte. I'm an engineering manager at Container Solutions, and I'm going to quickly use this to plug, hey, by the way, we're hiring. Hope Jonas isn't too mad about that. Yeah, that's my really short intro on me and CS.
All right, Adam.
Yeah. Hi, I'm Adam. I'm an engineer, consultant, architect at Container Solutions, helping companies for about 4 years now to adopt cloud-native technologies.
All right. Thank you very much. So I don't want to keep you far from getting to know the nitty-gritty details. Adam and Charlotte will tell you about writing your operator in Java. But to make sure we are all on the same page, I'll just have a few introductions about what operator is and how you should use Java in order to write your operator. So what is an operator? If you know Kubernetes, also you joining this session, I think you know a little bit about Kubernetes itself. But to keep you all on the baseline, the main concept behind Kubernetes is the ability to write something in a resource, in a manifest, so what you want to do, your so-called desired state, and then apply knowledge in form of code through a controller in order to make that desired state the actual state. That looks something like this. So if you program something to do it, you basically just have a YAML file or a JSON, whatever, where someone describes to you what he wants. This is called a so-called custom resource, where he can tell you, I want my app to be routed this way. I want to have 2 instances of my app. All of these things are just defined in some kind of manifest, and your controller, which is your main application loop, will iterate through that and try to make that happen. Yeah, that's the gist of an operator. Everything else, Adam and Charlotte will tell you when you actually write your own. With OpenShift, Red Hat introduced a new framework called the Operator Lifecycle Manager, because what we've seen a lot of growth in the operator space, and we've seen a lot of people using operators to deploy more complex scenarios. Something like a Kafka broker, for example, which needs Zookeeper and everything else, and you need to configure all of this, which can be automated by the vendor for you to make it more easy. But once you have this kind of software in your system, you need lifecycle management around that. So you need to be able to manage how to install that, how to upgrade it, how to delete it, how to basically do update streams. So once a new breaking change introduces, you are able to apply that change to your cluster as well. So what we did is we introduced the operator lifecycle management, which basically gives you 2 experiences when using it. The first one is the one for the cluster administrators. As a cluster administrator, you basically want to observe what kind of operators are available in your cluster, and you want to basically manage that lifecycle. So what we did is we introduced the operator catalog, which I will show you in a few minutes, where you can just browse operators available to you in your system. Running on Red Hat OpenShift, for example, you will only get operators which are certified or which are running on an OpenShift cluster. And then you get a very fancy UI to manage updates and the whole installation and being part of that. And basically for a cluster user, so for most likely a developer, it should be fairly easy to use that kind of operator. So once the cluster administrator installs an operator, for example, the Couchbase operator or MongoDB operator, as a developer, I basically just want to say, hey, I want a MongoDB, and these are my specifications for that. And this is the second part of the operator lifecycle manager, which will give a user the ability to see what kind of operators are available to him and use that within his namespaces, within his basically rights, basically the rights he has in the cluster. So this is it. If you want to learn more about operators, feel free to reach out. We can do more on that. But what I want to tell you too is why you should use Java for your operators. So why is making a webinar or making a webcast about writing your operator in Java a thing? Because the main concept of the history of operators, they are most likely will be written in Go, because Go being the native language of Kubernetes, all the interfaces already being available and stuff like that. We branched out that to be able to write operators using Helm and Ansible and stuff like that, which is all fine, all good. But when you look into the enterprise world, you see a lot of developers writing code in Java, and being able to use that knowledge for your operators is a good thing. And if we talk about Java, we talk about a language which was designed in 1995. And when it was there, it had quite of a different scope. The main thing behind Java was to write TV boxes and to be able to have a language which is independent from the hardware manufacturer. And this is the story of Java from 1995. And since then, it moved really fast into the enterprise world, into the server world, the ability, this slogan of Sun, of writing once, run everywhere, which basically every modern programming language will tell you it can do. But if we look at the charts, and this is from the 2020 State of the Octoverse report, you see that just this year, Python was ditched Java from the second place of the top language, which is my opinion mainly because the whole AI machine learning thing going big. But you see Java again as one of the top languages being available. And in my personal opinion, having to learn a new language just because you want to automate the deployment or something in your cluster, that's most likely not feasible and will slow you down in terms of performance. Another big thing coming or currently in the Java world is Quarkus, which is the Kubernetes native Java open source project, which is mainly endorsed by Red Hat. And what you see with Quarkus is the ability to write Java code in a very, very small footprint. And we talk about like 12 MB memory being deployed in 0.16 seconds, which allows you to write these operators without, or basically your whole application, without bloating up your whole footprint, without using so much resources just to automate something. And this is where the future of Java operators will have a nice standing, where you'll be able to use the language you already know in order to automate something around your deployment, and then use that without really having to think about how many resources that will take in your cluster. Yeah, so that's basically the really, really fast part of what is an operator and why should you write it in Java. I will skip that demo because we are already at 16 minutes. If we have time at the end, we can surely do that. But Adam, if you are ready, I would give you the screen and we'll give you time to show us how to write one. that okay?
Yes. Thank you, Jonas.
Yeah, one thing, I totally forgot that. If you have any questions, just use the chat or the QA part of the prime time. Charlotte and I are in the chat right now, and if we see any questions, we will be able to answer them right. All right, Adam, that's your turn.
Yep. Is the slide up?
Yeah, looks good.
Great. Okay, so today with Charlotte, we will be showing you guys the Java Operator SDK, which is an open source project that we started at Container Solutions while developing operators in Java, obviously, for a client of ours. So, and the project is nicely and slowly maturing now. We're actually teaming up with the Quarkus team from Red Hat. And yeah, let us show you what this SDK can do for you to make writing operators really easy in Java. And it will also show you a lot of nice details about what operators actually do, how they work. Charlotte is going to show a demo, so you will see working stuff today. First of all, why do we need an SDK for writing operators? There is all kinds of different things basically that are a bit tricky to handle with Kubernetes. An operator is basically a program running in Kubernetes, interacting heavily with the Kubernetes API, handling events from the API, and there is a great client library called the Fabricate client for Java, which is also developed by Red Hat, and you can do everything using this client library. But a lot of the things that operators need would be cumbersome and verbose, so the Java Operator SDK helps with them. One is how do we handle custom resource events? So they map nicely to a specialized class called the controller for you. You will see that when Charlotte is showing the code. Basically a simple interface that is very straightforward and you can easily implement it. So hide the Fabricate client nitty-gritty details. Listening to all kinds of events coming from Kubernetes also poses concurrency issues. There are certain things that are very easily handled concurrently, like events from different resources, but then you can get events for multiple events for the same resource, and those you don't want to handle concurrently. So this is going to be nicely managed by the framework. Finalizers are a thing. I will be talking about them in a bit, and we handle them. And finally, native compilation and working with Quarkus is also not trivial, and we are right now working on making the SDK completely compatible with all of Quarkus's nice features. And obviously, native compilation is done by GraalVM under the hood. So, first of all, some terms and how do they relate. The operator that we talk about is basically a process. It's a pod running on Kubernetes, and it can have multiple controllers inside it. So one operator can have multiple controllers. However, each of these controllers would be controlling a completely different type of custom resource. And for this reason, actually, many operators just have one controller because they're made to control like one resource. Like we will be showing today, controlling Tomcat. Well, yeah, actually the Tomcat operator will have two custom resource controllers. So for each custom resource definition on Kubernetes here on the right side, we will have a controller. And then, so the custom resource definition is like the class, and the objects would be the custom resources created for that class. And then the controller is the thing that handles all the events for this type of custom resource. So you can see the white resources are handled by custom resource controller 2, and custom resource controller 1 handles thing handles events for custom resource 1. How does this look in a bit more detail? Down at the bottom of the picture here, you can see the Kubernetes API. From the API, events are bubbling up through this chain of different handlers. So on the lowest level, Kubernetes events, the Fabric 8 client opens a watch to the Kubernetes API, and basically, which is a WebSocket connection, and keeps receiving events about the custom resources we are interested in. Then it sends these events into our default event handler, which interacts with the event dispatcher to do all the threading, filtering of events, etc. And finally, the event arrives in the controller where your business logic goes. So the whole point of the Java Operator SDK is that you don't have to care about anything else except this controller. Not the full story. You also have to care about event sources if you want to. So for all the events about your custom resource will be going into the controller. However, let's say you have an operator that is creating deployments on Kubernetes, or you can have an operator that is not even creating things on Kubernetes, but it's creating, let's say, a database in AWS, spinning up an RDS database. In that case, to be able to listen to events also about these other resources that are not your custom resource, you can create event sources, and these event sources will be sending events for that resource. So let's say an event source, if it's a Kubernetes related event, then you would also have another Fabric 8 watch, and the event source would be sending events into the event handler, which would bubble up into the controller. This is new functionality. This is the latest thing in the SDK, and we will unfortunately not be showing it in the demo because we didn't have time since the release of this to actually prepare for the demo, and anyways, there is probably not enough time. But this is an important new feature in the SDK. Once the controller processes an event, it will, in many instances, will want to update the custom resource, set a status flag, something saying, okay, this is now everything is up to date. And then that update will also be processed by the framework and sent back through the Fabric 8 client into the Kubernetes API and updated in this. Here is a bit more detail on what happens with all the events. So with the new event source architecture, everything is an event source. Basically, there is a hidden event source also that is handling the custom resource event. So in this bottom to top chain, there is also an event source. So if we would have two types of custom resources for our controller, then we would have we always have a custom resource event source working in the operator. And let's say we would have another event source for some type of resource that we created because of custom resource 1. So these resources are related to custom resource 1. Then, like in our case, we will be in the demo case, there will be a Tomcat custom resource, and we'll create a deployment of Tomcats. So that deployment is related to the custom resource. In that case, the framework will order all these events that are related to the same custom resource into one queue, basically, and the events related to custom resource 2 into another queue, and then use a thread pool to possibly parallelize the execution of everything related to custom resource 1 and everything related to custom resource 2. So custom resource 1 events will never be mangled, will always come in order, but custom resource 2 events will be executed in parallel. And it's in this case the same controller executing them, so the same controller would be called from two separate threads. Finalizers are an interesting feature of Kubernetes, which you probably, at least I never heard about them before I started working on this Operator SDK. Finalizers allow you to make sure that a resource, in our case our sample Tomcat custom resource, that this cannot be deleted without the operator having a say in it. So normally when somebody goes with kubectl to the API server, they just type kubectl delete Tomcat, they delete the resource, it's gone, and the operator might have been down at that moment, or for whatever reason, it didn't receive the event, then the resource is deleted, and the operator will never delete the other resource that's related to it. So that's a problem. And what we can do about that is we can add finalizers, which is just basically a list of strings we add to the resource. And basically, until this finalizer has been removed, the resource is not going to be really deleted. So you can type kubectl delete, and it will just block. It will wait until all the finalizers are removed from here. And at that moment, the operator will be notified that, hey, a delete is trying to happen, and it will execute the deleting logic of the real resources created for this custom resource, and will delete the finalizer, allowing Kubernetes to truly delete the resource. And so this is an interesting thing. For example, the Go SDK does not handle finalizers for you automatically. You can see we took a bit of different philosophy, aiming at Java developers, less aiming at like deep Kubernetes experts who know all these things. We just do this for you. You don't have to even understand what finalizers are. Currently there is a massive pull request in the works for creating a Quarkus extension for the Java Operator SDK. We will be fully Quarkus compatible, and and we're really proud of that, to have been like start up this relationship with the Quarkus team, and now working closely together to make Kubernetes native Java happen. So to sum up the story of the SDK, it was started by Container Solutions nearly 2 years ago. We started developing it on a real use case, but currently we don't have any production users that we would know about. Our uptake is not amazing yet, but we hope it's slowly getting better and better. We are getting more and more contributors also, so that's looking really nicely, and we are obviously teaming up with the Quarkus team. And on our roadmap, we have the event sources are actually there already, so this is slightly deprecated already, which is great. We're making some good progress there. We want to improve the developer experience further. For example, now the Java classes that map the custom resources have to be created by hand. We want to generate those, or we want to generate CRDs from the Java classes the other way around, whatever people prefer to do, whichever way. Create a project skeleton, which looks like will be done actually by the Go SDK. When you type language equals Java, it will create a Java Operator SDK project. We're also working with the Go Operator SDK team. We are thinking of adding reactive programming primitives into the framework because in the end this is an event handling system, so reactive programming would fit nicely there. Quarkus integration is nearly there, and and we want to take a look at the operator lifecycle management and operator hub and see how we can help interacting with these technologies, but we did not have time for that yet. And finally, we have 3 different sample projects. The Tomcat operator is showing a more complex application management. That's what Charlotte is going to be demoing in a moment. The MySQL schema operator is showing the case where you are managing resources outside of Kubernetes. So basically, this operator is creating MySQL schemas inside an already running MySQL database. And finally, the web server operator is a really simple one, just creating a very simple web server from a HTML snippet and displaying that will render that HTML. So that's the easiest one to get started with. And if you want to get started with your own project, basically the simplest way is to just clone one of the samples that is closest to what you want. Configure kubectl to connect to whatever cluster you want to work on, because the SDK will use it automatically. Create a custom resource definition for whatever you want to manage, and then write your controller logic that you will see how that's done in Charlotte's demo. So it's a bit of a manual process. We don't have an amazing getting started guide and whatever, but we are very available on. We have a Discord channel. You'll find a link on the website and on the GitHub page. So feel free to jump in there and ask us any questions if you're stuck. All right, and now I hand over to Charlotte. And during this whole time, I did not see a clock on my screen because of full screen, so I hope I didn't overshoot the time, but I think we're still okay.
Well, good. Thank you, Adam. Let me take over sharing my screen. All right. Going back to the code. Is the size okay, or should I go into presentation mode on the code?
I'll just go for presentation mode, I guess.
Okay. So as Adam mentioned, our operator is basically a collection of controllers. So what we have here for the Tomcat operator, which is totally not an endorsement if you want to do a JBoss operator, I'm sure Red Hat is super happy for that too. So the Tomcat operator is basically just an example of how you would have multiple controllers inside your operator. So you can see we're registering two different controllers, the Tomcat itself and the web application controller. Both of those are based on custom resource definition that we'll take a look at in a second. But first I will show you one of the controllers, Tomcat controller. And while this might seem like a lot at first glance, it's actually not that much because the only parts that you really need to get started are two methods. View mode and presentation mode. Those two methods are the create or update resource method and the, where is it? Well, I lost it. Okay, anyway, there's two. There's the create or update
There is delete
resource
is right
and there's
up there.
the delete resource. Yes, I scrolled past it. So those two methods are everything you need to tell your controller how to react to the incoming events. So you have basically different types of events coming in, and if it's a create event or an update event, your controller starts this method, and if you get a delete event because somebody deletes the custom resource, then you go into the other one. So those are two big parts that you as a developer will have to care about. And in our case, a big part of this is the watch, which will disappear with the next version of the SDK. And the part that you still care about are these two, for example, because this is what your controller / operator will actually do. In our case, the Tomcat operator really just creates a deployment and it creates a service. And you can take a quick look at these two. The method takes different fields from your custom resource and sets them on your deployment by talking to the Kubernetes, the client that we're using, the Fabricate client. And this doesn't, of course, mean that you have to create something Kubernetes. As Adam mentioned, you can have outside resources that you're creating. So you're fairly free to do whatever in those methods to choose what your operator is actually creating and or deleting. Okay. And I say we're quickly going over here. Let me know if the sizes are all right. Otherwise, I'll just get started. After you've created your first draft of an operator and connected your local system to a cluster, in my case, I'm just running one locally. As you can see on the left side, I'm using Docker for Desktop. And this is just pretty empty cluster, so there's nothing running at the moment except the base services. What we want to do as a first step is create a custom resource definition. In our case, that kind of looks like this. So we have two custom resource definitions. We have one for the Tomcat, and we have one for the web application. What you can do in a custom resource is pretty much define the way you want your Kubernetes resource to look like. So as you would have in a deployment, for example, a name, a namespace and everything, and different specs, you can have the same thing by using custom resource definitions. In our case, we don't have a lot of fields. We basically just want the version and the replicas. So those are the two fields that our custom resource definition actually wants in a custom resource. So the Tomcat has the version and the replicas, and the namespace has which Tomcat we're using, which URL we're using, and what the context path of the application is. Everything else is pretty much just a template outside for the custom resource definition. Now, if we go up a bit, if we look at our actual custom resource, I'm going to quickly hide my bar down there. Yep. So if we take a look at our Tomcat sample, this is pretty much it. So this is everything that a user of the operator will have to write. You will need the custom resource for a Tomcat, and you will need to define the specs for that. So if you have a cluster with an operator running, a user only has to have this, apply this to the cluster, and then the operator will do all the rest. And for good measure, let's take a look at the web app as well. In our case, that's just a simple bar file, and it's going to be using the first Tomcat that we actually have. So let's get started with applying the Kubernetes custom resource. You can see we created both custom resource definitions, and they were just created. That's great. The next step is we have our operator. What I can do now is basically run the operator locally, and since I have kubectl configured, it would connect to that, and then while running the operator locally, I could still use it. But this is only something we use for development. So if you're testing your operator, you don't have to deploy it to the cluster, but this is something we want to do. So we build our project. We have a automated Docker build in there. So what this is doing is actually building a Docker image of the operator. There is a little funny thing about that, which we will see in a second. But you can see it is building the image, adding the Tomcat operator jar, and pushing it to my local Docker daemon. Okay. I hope this only takes a few seconds longer. For some reason, it's always a little bit slower when on a demo, but that's done, and that went well. And now we can actually see that it built that, but for some funny little bug, it thinks it was created a lot longer ago than it should be. Anyway, we're using this Tomcat operator image locally in our operator deployment. Take a quick look at the operator deployment. We're creating a namespace for the operator. We'll use a service account. This part is pretty important because you want your operator to have pretty much all the rights that it needs on the cluster. So we're giving it, in this case, cluster admin. You can reduce that to whatever permissions you actually need. And then we have our Tomcat operator as a deployment. It's a fairly basic setup of just creating a Tomcat operator with one replica. And here is the cluster role binding for our service account, so that the Tomcat operator actually has the rights to contact the API and create resources and register the watches. Okay, so we don't do that yet. Let's take a quick look at the pods. If we were to apply a custom resource with just the custom resource definition on that, not having an operator running yet, I guess you can imagine what happens. We do have a Tomcat now. It's there. You can see it's the one that we looked at earlier. you can also see nothing else was created, which makes sense because we don't actually have an operator yet. So we'll delete that again and actually deploy our operator. Created the namespace, we created a service account, the deployment and the cluster role binding, and we can see our Tomcat operator is actually starting up. Let's take a look inside, look at the logs if everything's actually going well. This might take a few seconds for the operator to come up, but it should not be that slow. Okay, this is not something that we want. Okay, now it's starting up. This took a little longer. This is the point where your heart stops for a little second and then you're like, oh no, this is a live demo. Why am I doing this? Anywho, operator is starting up. Going to take a few more seconds before it's actually in ready state. But until that happens, we might as well just apply the Tomcat again, because even if the custom resource is there before the operator will still get the events. So we probably could have just left the Tomcat there as well. And then when the operator is ready, our resources that we defined in the create or update resource method inside the operator or inside the Tomcat controller, actually, those will be created.
Yeah, something's not right there.
Yeah.
Oh, it already restarted.
Longer than it should. Oops.
Yeah, maybe try to run it locally then. Found service account.
That looks okay.
Keep it on this screen, because otherwise we'll not see why is it restarting. It restarts again.
Yeah, my well, you get to see live debugging. That's also fun.
Yeah, you will have to keep the log screen on, because what happens now is that the operator restarts and the logs get deleted.
Yeah, we want the error message to make sense.
Or we just move to running it locally. Knows what's the problem now.
Problem is that my keyboard is not doing this quickly enough, so I'm pressing keys, but it's not doing anything. But yeah, let's use the developer version, I guess. And run our operator.
In the end, it doesn't matter whether it's running on Kubernetes or locally.
I mean, in production, you do want it to be running inside the cluster.
Yes.
Okay, now it's starting up locally. And you can see, so all the events here, it already realized that it has a Tomcat there. And I'll actually delete the up.
Probably shut down the operator that's trying to run on Kubernetes just in case, so it doesn't interfere with the local one.
I totally would, but I seem to have lost control over my screen.
Oh.
I can't type anymore. This is just a second. Let me see if I can get this back.
Oh, you have like 55 restarts of Kube Scheduler Docker desktop, so something isn't right.
Something
with
is
your
going bad.
cluster. Just while we're debugging it, just to give everybody the picture, this is a Kubernetes now running on Charlotte's laptop. And
which is probably the issue. A second.
Yeah, normally it works, and it's not a live demo. Maybe you restart the whole Kubernetes. Yeah.
Well, if you want, I can give you access to my OpenShift cluster. That helps.
Actually, yeah, that would be great.
Do you think you can set that up that quick, the connection?
I mean, I just need a kube config, right? Actually, it was creating. Dum dum.
Oh, right.
I'm not sure when this stopped working. It's like my iTerm is broken.
I think it's gonna be easier to just wait for the Kubernetes to come up again then.
Yeah, but I can't do anything on my shell. Dum.
Like it's not just the Kubernetes window, but like the
entire thing.
okay. And for skill?
I tried.
Nice. I haven't seen a live demo fail this badly in quite some time.
Yeah, that's always the nice part, right? Actually, I mean,
Like that even the
I like
console,
it.
not just the cluster and everything.
So I sent you a login command to my cluster if that helps. Can't access your shell, maybe that's.
I killed it from another terminal, like different type, because I think it was an iTerm issue.
Okay, well the Docker for desktop already restarted. Maybe
Yeah,
Kubernetes.
Kubernetes is still coming up.
Okay, that's real fast. Or actually, the quick thing is that I take over the
Do you have it there?
I'll just let's wait for like a minute, and in the meanwhile, I'm setting things up here just in case.
Yeah, Kubernetes is still coming up. Okay. Oh, yes, I broke my cluster completely. Interesting.
Okay, so I'll take over then.
Yeah, I'll stop sharing. Thanks, Adam.
Okay. Screen. I hope I didn't really try this in a bit, but yeah, let's hope it works. Okay, so I have I think I have some Tomcat deployed on my Kubernetes cluster. Yes, I have test Tomcat 1 there. Let's see what it has. It's configured for 1 replicas version 9, and it's already running with 1 ready replicas. This status has been written here by the operator. So basically the spec part is an input for the operator and the status part is an output from the operator. We can see the Tomcat running if I get deployment and pods. So here is the Tomcat deployment that has been created by the operator. And here is the pod that has been created by the deployment. So we are using these higher level Kubernetes constructs like deployment and don't control pods straight, although we could do that if we chose to for some reason. Now that we have the Tomcat up and running, we also created a service. We type load balancer. So my cluster is actually running on Google Cloud. It's a GKE cluster. We have an external IP. and this is where this Tomcat is exposed now on this IP address. So that's great, but we also want to deploy some web application into the Tomcat. And first, we also want to see the operator actually do something. So I will start it up. And now, everybody, please hold your breath. I really hope this works. I was starting it yesterday, but okay. So yeah, it seems to be running, connecting, all that stuff. That's great. So let's just edit our Tomcat test Tomcat 1, and just if I edit it now, I will set, let's say, replicas to be 5. So I want to run 5 instances of my Tomcat, very high available setup. Watch kubectl get pods, and you can see I'm not using that fancy Kubernetes thing as Charlotte, though that looks much better, but this should be good enough for now. You can see more Tomcats just creating on the cluster. One of them got created real quick. The others are starting up. Okay, all Tomcats are running. So now we have 5 instances of our Tomcat, and this all has been done by our operators. You can see a lot of logs here. So what happened was this creator update resource method got called again. I'll zoom in. This method got called again, and this Tomcat object had the right amount of replicas in it. You can see this is a Tomcat object. It has a spec, and there is the number of replicas in there. I could also change the version of the Tomcat, and then that would roll over all the replicas to the right Tomcat version. Yeah, so this method has run, and I'll explain what happens here real quick. What happens is we register a watch on the deployment that we create. So when the deployment actually scales up, so when this deployment that we were watching here actually gets to 5 replicas, we get events about that too. So the operator can then update the Tomcat object can update the status to 5 ready replicas. So we are also reacting. We are watching our resources that we create and then react to that. We are just doing a status update here, but you can imagine we could do way more. This is where the power of operators comes in. When you just use Helm to deploy things to the cluster, you can't react to what actually happens with those resources later. Okay, now let's take a look if I have any web apps created. So I will actually delete these.
If you want, I can take back over. My cluster seems to be doing better.
I don't mind. Do you want to take over from here? Do you want to take it back?
Sure.
Okay. Let me give it back to Charlotte then.
Okay, so basically at the same stage Adam was at, except now we're applying the web app. So web app 1. So the Tomcats were up from what the operator did. We can see the web app is added as well. And if we take a look at it, it's using an example var file and using our test Tomcat. That one then shows up on my localhost. I don't actually have a remote cluster, so this is a node port and not, yes, so we can see there's a Tomcat running, but not the correct application that we started yet. If you look at this, we sample a var. Oops.
Check the
It just my browser takes a little longer sometimes to undo the caching. So now there's the sample application that we deployed with the web app, and let's say we want to change that. All we have to do is edit the web application and use a different URL.
By the way, this is a really crazy sample where we're deploying WAR files into already running Tomcats. This is not meant to be any kind of production scenario. This is just to show the power of operators where you can like put this abstraction layer over any application and just control it from Kubernetes.
Yeah, so the idea is to have some sort of application that we can show how an operator actually works. It's not about that you should be running a Tomcat like this. In general, you would use it as a base image and then just load your application into it, or not load it at all, just have it as your image. But this is just to show how different controllers can work together. So in our case, we loaded the web app onto the existing pod. And yeah, so we replaced it with our sample application. And now if we do the opposite, we basically just delete everything again. And the delete of the custom resource causes the operator to then delete all the resources that we created. So if we take a look at the services, also the service that I had for the node port, that's also gone now. And then if we stop back, that was it for the demo pretty much. If we go back into what we actually did, this is a simplified example of what's actually happening in the Kubernetes backend. So when we run kubectl apply anything, so we created the custom resource definition and we created the custom resources, so the Tomcat and the web apps, and creating those sent events to the operator. The operator was listening to those events and then created the resources it was supposed to. And as we said, they don't need to be Kubernetes resources. You could have a S3 bucket that's being created or an EC2 instance or whatever you can think of, really. All the other parts that were happening, for example, creating the deployment and creating the pods, this is something that Kubernetes already does for you. So the whole getting the events, and then you already have controllers, the deployment controller and the replica set controller, for example, running. So those take care for you inside Kubernetes to create the replica sets and the pods, and then actually schedule the pods for you. This is just to show that the operator is using pretty much native Kubernetes paradigms, I guess, to actually do what it does. So you're literally extending Kubernetes with an operator. That also means you get the same functionalities that you would if you are creating a normal YAML file. So for example, input validation. So you can define, if for example, the custom resource that we had with the replica, that is supposed to be an integer, that you only want numbers in there, so people don't actually do wrong inputs that you wouldn't want. So you get all of those on top because you're using an operator as an extension of Kubernetes. We only showed a very basic example, so the very basic installation and small upgrade. That's only the first step of what you can actually do with an operator. The operator SDK has different maturity levels, the way they scale or the way they basically put their operators into categories. There's 5 different ones, so the basic install that we did and the seamless upgrades are the first 2. And then after that, you go on to full lifecycle, so storage management and application management and taking care of literally everything you want for your application. The next step after that is you use metrics on your application or on your running resources, so you don't actually, you'd still have like a Prometheus running, but you can use the operator as well to gather insights into that. And then once you have those, you can actually use the insights from what you're using to create basically an autopilot. So there's a book on operators that actually describes operators as tiny software SREs in your cluster. And I think that's a nice image for how you can actually get an operator to do what you need it to do. You basically want it to do all the operational management of your application for you so that people using your application don't have to think about it. Okay, that was it from my side. Do we move on to the questions?
So we are currently not having any questions in the chat, so feel free to write them as you have anything you want to operators or Kubernetes and stuff like that. While our audience is writing all the questions they surely have, I have one for you. Can you, like you guys wrote a few operators like in a business context right now. Can you give us a small example of when should I as a developer think about, hey, I should use an operator for that?
I can talk about the business context that we use them in. We were provisioning, basically we were creating an enterprise level CI/CD system on top of OpenShift, which meant provisioning a ton of resources for every team when they were getting onboarded, like Jenkins pipelines, Jenkinses, Git repos, and so on, like whole bunch of stuff needed to be provisioned for every team. And basically Terraform was failing us in sense of like it didn't have for a lot of the resources we were using, it didn't have providers for it. So we just first started implementing these things in Java because our team actually had a lot of Java skills and we didn't have Go developers. And then we realized that, okay, where do we run this code? We could just run it from a Jenkins pipeline, but that was getting awkward with like Jenkins being responsible for just too many things. So we decided to move all that code into something that runs on Kubernetes, runs close to the place where most of these resources actually need to be created. And once that code moved into an operator, actually we created a set of operators for all different resources. Every operator was there for each type of resource. There was an operator. And once we did this, we realized there is a lot more we can actually do, like lifecycle management, like things like how do we delete a temporary development environment from a Jenkins pipeline that was not possible because it just created it and it was over, while the operator could actually monitor these environments. And once they were orphaned because the branch from which they were created has been deleted, then the operator could delete the environment also, and all this kind of things it could do. So that was our first project done with operators.
Generally speaking, I think you can go for anything that's a repeatable task and anything that's fairly application specific. So for example, data management. If you have an application that's connected to a database and you want to, for example, run that inside Kubernetes, then you could do like the management of the storage parts. And because that's something your developers, for example, don't need to know about. This is just something that if you want to have a backup, if you want to have an upgrade or something, those are things that are good as basic concepts, but you don't actually need to have it specific. So to create an abstraction.
Yeah, and both from infrastructure, and like the ops can create an abstraction for developers to use, but also developers can create, let's say, an abstraction like we did with the Tomcat. We abstract over the details of how you run the Tomcat, and that's useful for operations then. So developers can create an automation layer on top of their application.
Yeah.
Okay, then we have one question from Surush, who's asking about the definition of an operator itself. And he's writing, wouldn't the controller called operator if it's not working with custom resources, but just the standard resources of Kubernetes, e.g. a controller that listens to pod events and does something more than what Kubernetes controller itself does? So as far as I understand it, at what point a controller is becoming an operator? Or what's the difference between the two?
Yeah,
I would say never, to be honest, but that might be my opinionated version of it. Because the controller is always part of the operator. So even if you're not extending the functionalities by much, it's basically the custom resource plus operator part. Since you'll always have the custom resource definition and the custom resource on your cluster, plus the controller. So the operator is always more than just a controller.
Yeah, I don't think there is like a very strict definition. Yeah, the definition, our definition that we use in the SDK is what Charlotte said. Like operator is a collection of controllers that then the controllers do the logic. In Kubernetes, I think the core controllers are just called controllers, and I think how the term operator came around was when CoreOS started advocating for, hey, let's use this pattern of controllers from Kubernetes to also create controllers for other things, and let's call these operators. There is not like a very, at least as far as I know, there is no clear line. Yeah. By the way, a shout out to Soroush, who's also pushing pull requests for the SDK. He's one of our contributors.
Then we have another question about the next version where you can add external events as sources. Can you elaborate a little about what kind of events we can pull in? Like, are we using Kafka? Are we using webhooks? Or is that abstracted via Knative, for example? Can you say something on that?
Yeah, it's abstracted completely. Like, we don't deal with what kind of events you have. So there is no, the internal event handling inside the framework is just simple Java stuff. There is no like heavyweight system in there. And the external events, when they come in, they just come in through an interface. So basically you have to create an interface to work with AWS API events or whatever other events. Even, let's say, in the case of what I want to implement and didn't get to it yet is in the MySQL schema sample. Let's say when you're creating MySQL schemas in a database, you don't get events at all. So you don't know that somebody deleted the database, let's say, or stuff like that. However, by creating your own event source, you can fake those events by polling the database server. So that would be also like, it's an adapter layer that just turns anything on the outside into like these internal events in the framework.
All right, then we have the last question currently about finalizers. I answered it in the QA, but the question itself is, if the operator is not running in the same namespace as the managed custom resource, and we are deleting the namespace itself, how can we prevent Kubernetes or OpenShift from revoking the operator's access to that custom resource that has been deleted itself? So basically, I have an operator running on a cluster level. Right now, we show the same namespace level, and someone is deleting the other namespace, which would delete the role binding for that operator to operate in that namespace, maybe, depending on how we do it.
Unless I'm mistaken, that's not how things work. So the role binding doesn't get deleted because you delete the namespace, and nothing basically gets deleted because, so what would happen is you tell OpenShift to delete the namespace, then it will start deleting all the resources in the namespace. It will bump into your custom resource having a finalizer, so that custom resource will not be deleted because it has a finalizer. So the namespace also has a finalizer that prevents it from being deleted until all the internal resources are deleted. So nothing really gets deleted until the operator actually removes the finalizer from that resource. And I think the role binding even survives the complete deletion of the namespace, unless you created the role binding inside the namespace. Yeah, okay. In that case, if you created the role binding inside the namespace, then that could happen. But I don't think you would do that for an operator. You would just give the operator a blank, like rights to all namespaces, pretty much. Well, usually, like, okay, you
depends on the use case there, however you want to do. But I think the important part here is to know that the default finalizer for a namespace is there, and it's basically saying don't delete the namespace until everything within that namespace is deleted.
Yeah.
Which will give you the opportunity to delete your objects. Which is.
But now I see that this could actually happen. It could happen if you created the role binding inside the namespace, which you don't have to do, but you might. And in that case, it might just the deletion might go through that before it bumps into your custom resource, and then you might have lost the right to actually remove the custom resource.
So I'm actually not quite sure. I have to test that, but I think role bindings are one of the last things we delete. Because of that reason, to say, okay, the last things we delete are service accounts, role bindings, and stuff like that, in order to make sure that we don't pull something the rug under.
Right.
But what I want to give a quick shout out to that question, and give you a small hint about software reliability engineering. You ever see an object in OpenShift or Kubernetes not being deleted, and you say, hey, it is deleted, there's probably a finalizer somewhere. And you have to check each and every resource for that finalizer. And the brute force method to make that being deleted is deleting that finalizer line.
Yeah, just editing the resource, deleting the line, and that's it. Yeah.
Yeah, but you have to make sure that whoever was blocking that, does get resolved. But I've run into that. That's something to watch out for.
Jonas, you're muted. You just muted yourself. You're muted.
Yeah, this happened to me a few times now.
Your computer just decides it's had enough of listening to you and you're muted again. You're muted again.
This is not working.
I'm glad I'm not the only one with computer troubles today.
We hear you now. You're.
Oh, you hear me now. Okay, that's good. Yeah, this happens if you click too fast on the mute unmute button. Sometimes BlueJeans just decides if you are muted now or not. This is the same what I wanted to elaborate on for validating webhooks. If you can't get an object to be created, there might be an validating webhook which is blocking you. This is just something I've run into. I want to put it out there. If you see something not being deleted, probably a finalizer. If you see something not being added, probably a validating webhook. So this is everything we have for today. If there are no further questions regarding that, we can cut this down. Thank you very, very much, Adam and Charlotte, for doing the presentation. It was really great. I'm really looking forward to the future of the Java and Operator SDK world, and now you guys are working heavily with Red Hat to make it part of the official Operator SDK. But really enjoying your move forward into making operators available for Java developers, and make sure to watch out for container solutions. Make sure to watch out for Adam and Charlotte and what they're doing. I think their Twitter is very active, and you see a lot of updates about the project itself or other things.
Yeah, and
thank
please,
you very much.
I'm sorry, Joe.
Good. Again, I want to close it up.
Just want to say that don't forget that we to check our GitHub page and the chat we have. Jesus, what's not Slack? The other thing. Discord, yes, the Discord chat. So feel free to jump in there and ask questions. We're always there and happy to help, and we're always welcoming contributors to the project. So if you want to join, we have weekly meetings, and we are very happy to see more people help this effort.
Perfect. Thank you very much for joining us today. I don't actually know if the recording will be sent to you via mail. I guess so. Otherwise, please reach out to one of us, and we will forward you the recording as soon as we got it. Thank you very much, and I hope you guys have a wonderful week.
Yep.